Okay, so hello, bonjour, good afternoon, and Auf Wiedersehen. This is a movie where I am trying to, well, to figure out. This is a very old question of mine. How hackable are these LED bulbs are? How hackable are can they be? And I've experimented with them for a while, and today I will present to you I will show you the voltages they are working, the categories they are fitting in, and my project, my practical project, this lamp that is now working already with this LEDs from one of this power LED. So I managed to hack it, but I'm not completely happy about it because it's very fragile. It's the fragility of it. I really dislike it. So I will show you everything, but this is the main idea behind everything that I'm showing you here. How hackable are these things? These LEDs with aluminum heatsink underneath them. These light bulbs, LED light bulbs, and on my testings and my practical project that I really had to use them and very cheaply, very extremely cheap, because if you manage to hack it, you are getting a very good, extremely good product and extremely cheap. You know, it's $1 one bulb like this. So $1 or $2. If you three at $2, you can get those offers. 3 light bulbs at $2. So yeah, I will start explaining the project, and then I will come back and test them and show the tests about them, and with my multimeter, with my power supply, sorry, with my power supply there, and my multimeter set on to check the amperage, yeah, see you in a couple of seconds. 3, 2, 1, lift off. Pew. Yeah. All right. So my little project, I had a very good idea actually, and I'm very proud of the results, but I want it a little bit better. But let's start with the beginning. Practically, I used a LED bulb. This aluminum heatsink for the LEDs, for the power LEDs. This is from some other bulb, LED bulb. But this is how was looking before. This is having 15. It says here. What I do? Yes, 15 LEDs. 1, 2. They are numerated actually. Good for them. And but mine, this one, had 8, and I was very lucky. I didn't think it will matter. The number of the LEDs, but it does matter a ton. For the manufacturing process, I mean, while I was trying to make the thing work, using only 8 LEDs like that was fantastically well, easy, a little bit more easy. So that's the original. I had some pictures from before when I disassemble it. So as you can see, there are 8. There are some numbers as well. It's starting here 1, 2, 3, 4, 5, 6, 7, 8. As you can see, this is the circuit which I copied. I looked very closely with a magnifying glass on the tracks, and also with the multimeter set on diode for checking the shorts, the short circuit. If it's the same track, I just basically checked if this is connected to this one, and this is how I figured it out more precisely than visual inspection. I figured it out the entire circuit, which is not that big. So it's 8 LEDs as well there, and here are the values for these components that they are on. This is actually is looking like a transistor, and it's that one, but it's actually integrated circuit. It's a LED driver. That's the rectifying bridge, which is that one, and I copied the exact same circuit and position on my drawing here. And this is the back of it. You can see the capacitor here that is getting out through that plastic little thing through the you will see it live as well, and this is the full drawing. Okay, so this what it says here, I hope I'm not sure if you can see, but I will read it for you. 5 watts, 4000 K. This means the color of the light. I know for sure it's the color of the light, how cold or how cold, heat and hot the light is. 470 M, I don't know what is this, and 43 milliamps. Okay, works from 220, which is in China, 220, and 240 volts, which is in Europe, at 50-60 hertz. Made in China. Imagine that, made in China, and this funky number. And let's see, this is an inverted 8 here. It probably says about how many LEDs are inside. Hopefully 19 LC. I'm not sure what that is. And here it says, let's see, IBRS. IBRS. IBRS is the first. 10 40 61 5600. I suppose that's actually the real color of the light, how cold it is. V, B, and N, and Pila, and some garbage stuff. All right, so Pila. Pila probably it's the name of the company. So this is the LED. This is the bulb, which is empty right now. This is the case of it, and it's very hard to take it out. I hope I can with one hand. Yes, but I couldn't take it out with one hand at all. In the beginning, I had to use a lot of force. So this is the interior. I took it out very professionally. I took it out, and I didn't waste any wires on it. Okay, so this is the 1-to-1 drawing, which helped me immensely when I put the LEDs on this signs that I made here. I made some signs, And this is the lamp that is mounted right now, but I will dismantle it again to show you the details of it. And for comparison, to compare, this is my right side lamp, which is having a 5 volts power supply on it, but this is the entire bulb from 220. Check the, I hope you can see the difference. It's just boom. It's fantastically bright, and I like it. I love it, actually. I love it. This is very pale. Is is not even half power from this one. It's just but it's good. Because of it, I could manage to make to repair this one back. Actually, I will leave it on, and I will close this one and show you the interior that is already made. This is how I make it, and as you can see, I cut all of those 8 LEDs, and the power source is somewhere here inside here. The little what is called the little board is powered through this wire directly from the 220 through this exactly like and this was actually the original driver for the neon that burned. I don't have the neon anymore. I just smashed it. I took some wires from it because of some connections here. I will show you later. And yeah, that's it for the and it's working perfectly. I'm so happy with it. But the only thing is, it's that I'm not happy, and I really have to do a bit more research and more experimentation, and to test more, is to make it more solid. Is all this work that you see here is so fragile. You have no idea how fragile it is. It's very, 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 very fragile. I don't like the fragility of it. If I'm bumping it too hard, something will break from there, and I really don't like it. I wished to make it a bit more solid and not such fragile like it is right now. All right, that's it for this part. All right, this is the back of the lamp, the part where the driver circuit is. So this is the real and the cutted circuit driver. I wired everything, and this is having here a resistor on the wire. Here it's 21 ohms. I measured the entire wire. I measured it to figure out the value of that resistor, and I link it to the switch and to the mains here, and then the red and black wire is going to the LEDs through there. And yeah, practically this is what I did. I cut it and reshaped all the LEDs that they were like this. I cut them and reshaped them there. All right. So this is a piece of cement. It's actually cement. They put here for weight, and it's very, very good. I really like the, well, it's cheap. It's good. It's a good way of to put weight on this base, not to fall down. So this is how it is looking in interior on the base side, right? Nothing very important to see. By the way, in comparison with this one was somewhere there, for the do you see how small this one is? It's fantastic. It's phenomenal. I really love the size of this board comparative with the one for the Neon driver. That's the Neon driver that it was before. So I'll take it out and throw it away. Goodbye. Alright. Alright. I decided to actually dismantle it live. And hopefully I can make the tests. This is summer, it's hot, and you can see my monkey hands here. Hopefully it's not hopefully is sexy enough. Oh shit, I have to take out that screw there. But I will not disassemble it from there as well, because well, I will only show you. This is not plugged in, so it's very safe to work. I actually used this piece of plastic with its connectors from the original neon lamp. Here was the neon lamp, and I'm checking the video to see if it's good enough, and I marked here with my pen with my marker, actually my black marker. I marked the plus sign and minus. They had on them a little circle, a little dot, but after I cut them, that little dot was on some was still visible, but on others wasn't visible. Here, this is the original. I use my trusty knife here. This is the original metal strap that is holding metal holder that is holding the glass, the mirror, the magnifying glass, and is screwed here in this plastic. And this plastic was broken in two places, and I had to repair those as well with my usual 3D manual 3D printing with a little bit of plastic, and now is probably better than it was new. How well everything fit right now, and the screws. Before the little plastic was broken and it was very loose, probably from the weight of this magnifying glass, and probably I shook it out. And here is melted. I melted the plastic, and I linked this wire through to plastic through this to this holder. All these holders, 3 holders are, and I will not take them out. What I did, I took. I hope I can reach it fast enough. And it's somewhere there. Ah, shit. No, I can. But I took. Yeah. Are you here when I need you? No, you are not. Ah, yes, you are. I find it. So I took a piece of wire. Long. This was a bit more longer than this. It was having some problems on the plastic. It's used copper wire with insulation, and that insulation was formidably used in some parts. But I use it like that. Like you see here, is twisted, the insulation, and I use it because nobody is seeing it. But it's not from the heat from here. It's not even close. So I kind of use the garbage insulation at least, but the copper is fine, and I use this kind of. Actually, I'll measure it for you if you really want to know. And is 1.4, 1 millimeter and a half, almost 1.4 millimeter. thickness. And these pads are very little, and it's difficult, this thickness, to solder it. It ruptured very quickly from that soldering points. And I got one case when the copper just peeled off. I had one, and I had to scratch another piece of white, what is called, white ink, no, not ink, the fuck, I don't remember the word, and the white color that is used here, I had to scratch it and to unveil, to discover the next part of the copper track. But it's very limited, because it's it's that's it from here to here, and I don't have too much room, so it's very fragile from this point of view. But there are other points of view from why it is fragile. It's not only this, but also the entire ensemble is very fragile. It's working, is good enough, is supporting trepidation or stress to a point. But if you are not careful, if I have to transport this in a bag or in a car to another place, probably on the other side it will break something somewhere. So I don't really trust it, and I want, the next step is to make it more serious, more stable, more powerful. These connectors are very cute. I really like. I cannot open it right now, but I can tell you it's a cylinder like this one here, which is the outside. And on the other side, you can see here a wire, and see here another wire. These are actually from the neon wires. I broke the neon, and I took its wires, and I inserted those wires inside these tubes. They are hollow inside. They are like little tubes, and another little tube that is entering inside it with force, and that is the wire, and this is pressing it, and it's very nice mechanism, very nice connector. I really like it. And I put this wire as well here. Here was the capacitor before, and I put this jumper wire here to preserve those little jumper studs, how they're called, pins, like a pin inside, to preserve those, not to hold them away from this. Maybe sometimes in the future I will use them, who knows. But for now, this is how I build it. Now let's test it a little bit. Let me show you. Do I have time? Yes, I have time. Let me show you let me think a little bit. I want to show you the voltage in one single LED. Let's see how I can do that. Okay, let's risk it like this. So come on, like that. All right, and I will use my power supply, and I will show. Hopefully, I will be able to show it. To show in the same time. I'm not sure if I can show it in the same time. Let's put the jumper wire here. I hope you cannot, you are not seeing my baldness, because I am a bald person. I don't have hair. All right. So this is the safe way. Let's see. This is minus and this is plus. Actually, I put the red wire correctly on the plus side, and the dot signifies the minus of this particular LED. These are extremely weird LEDs. I never seen such LEDs, power LEDs actually, they are called. Very, very weird voltage. You will crap yourself. Hold your underwear and hold your stick, because they are working on 32 volts and 1.2 milliamps, but until I reached the maximum it was under 1 milliamp, and it was bright enough, but the visible light that I can work with, that's what is important. That's what I wanted to achieve. That's what I wanted to test it actually, because I tried other stuff as well, as you can probably see it here. Okay, let's start it. So this is my power supply. This is my power supply. I'll put it to, now it's on 5, but I'll do it on the maximum 32 volts. It says there, it's everything is on maximum, nothing, and is not truly limited. Here is kind of in the middle. I think it's 5 amps, and right now it's somewhere in the 2 amps range, but that doesn't matter because it will it's voltage dependent. This LED is voltage dependent. Let's see, it will go boom, or it will light, and you will see how crazy this thing is. So let me connect the minus here, and as you can see, it's working fine. And is not, this is not actually the real, you see, this is not actually the real voltage that is working with. How I figure out the amperage, I use my dinky multimeter. If you really want, I can use this to show you as well. I have a little bit of time, but okay, I hope I can make it here. All right. Oh, that was quick. That was good. That is good. And minus plus here, because I link it to the plus, and it's still 32 volts, as you can see. Ta-da! And okay, do you see my multimeter? Okay, and where are you? And you can see the milliamps. Yeah, it's showing minus because I inverse the wires. But if I'm, so it's come on. Why do you show me 2.2 milli? Yeah, it's phenomenal voltage. It's phenomenal voltage. 30 fucking 2 volts. I'm fucking believing. And it's actually on my maximum voltage of my power supply unit. It's fantastic. But yeah, I couldn't believe it myself, but then I start to think about it, and I realized maybe it is high power, high voltage LED, and I push it up from 500 millivolts, so 20 to 20.5, then 21, then 21.5. So from 500 millivolts step up. I step it up. My hand was hurting me, but I managed to reach the opening stage. Okay, that's it with this test, and I hope you like it, and I hope you believe me, because these are power LEDs. real power LEDs, and they are fascinating. And my impression and my what I think about them is they are made by Chinese factories there, and specifically to work with a certain circuit, the circuit, the board circuit that I showed you here, and I don't have that page here on my hand. No, it's not. But with that specific circuit, so these are kind of custom LEDs, and that's why I think it's near to impossible to find the datasheet for them. If someone can find this kind of datasheet, my hat is off for you. But I will show you next another type of LED, more usual. These types of LEDs actually, they are 8 volts and a little bit higher current. I think it was 130 milliamps per LED or 120 milliamps per LED, but way more lower voltage because they are many displayed or linked here. Okay, let me pause and start again with after I will make this lamp whole again, and I will reassemble it, and I will came back and I'll show you the other LED with 8 volts and the test, and I will show you the test. And yeah, it's fascinating. I am fascinated already. All right, that's it. All right, so I mounted it back, my lamp, but I will keep it closed because it's way too powerful. And as you can see here, it's 8 volts. And I will test the good LEDs and the bad LEDs, and I had 2 piles of them. Actually, these boards that I have here, do you see that little black dot there? And do you see there is nothing and there is nothing, there is nothing? These are actually burned light LED bulbs, and I kept the LEDs of it for future testing, and that future is now, because I truly test the shit out of them, and I now I have a very good idea what I want from them and what I can do with them, and what power they have, and what voltage they work with. And yeah, I'm very satisfied of the tests that I did so far. So to understand the idea behind it, where they are coming from, and they are from the commercial light bulbs, and I take them out and test them and hopefully use them. So it's by the way, it's still 8 volts, nothing changed. I just talked until now, and let's test it right now. This is bright. I cannot look at it. It's like welding bright. It's so fucking bright. It's like welding bright. And on the, yeah, it's for some reason I'm not making contact good enough. Huh. Well, it's pulsating for some reason, but maybe I'm not making the contact good enough. And you can see this one, how shitty it is. I mean, yeah, it's lighting up, but it's so low power this I mean the luminosity power, the light power, luminosity power, and this one is kind of the same. But it's a bit different color because it's from another board. They are separate. I have them combined. I didn't, I just say these are bad, these are good, and I have a few of these good ones and a lot, 27 bad ones, not completely burned, but they are still working, still on the same voltage, same 8 voltage, but the amperage differs. For the brighter ones, the amperage is much more higher. Right now it's showing me there, I'm not sure why it's pulsating like that, 120 milliamps, and for this one is not showing me anything. At 8 volts is 0 amps, so it's probably 10, less than 10 milliamps, less than 10 milliamps for these ones. Actually, I did all the I'm so stupid. I have all when I test them. So these are the bad LEDs. These ones I test them on 7.6 until 8.2 at 6 milliamps, like I said. And for the good ones, let me check. The new LED. Which one? This is, yes, this is the I think this is the new, the good one. Oh, I don't remember. Yeah. 8 volts, 160 milliamps for the good ones. And for other ones, I have another list. If I have it. I don't have it. Yes, I have it. So these are the brand new power LED that I actually used, and on 32 volts, this is the voltage and this is the current list, and maximum voltage of my power supply unit is 32 volts. I reached the maximum at 1.8 milliamps. Yeah, I said 1.2 before. Yeah, so it's it was showing me 2.2 or something. So it's around this number, around 2 milliamps. Yes. So for this super, but it's just fantastic, how much voltage you have to give on them. But I think they are custom made, especially to work as 8 LEDs, no less, no more than 8. I think they are specifically engineered at this higher voltage and this low, very low current, because it's very low current, and the brightness is phenomenal, and it's very interesting circuit. I really like this circuit, and the integrated circuit actually is around this integrated circuit. The entire thing is built around. Well, that is the bridge rectifier. Sorry, this is the integrated circuit U108-2G, which I find a data sheet about something similar, not exactly this one, but the circuit was the same in it, and it was specified that this is a integrated circuit for LED driving. This is actually the circuit that I borrowed. I copied from the original and put it here on the paper, and then compare it with the data sheet, and figure it out that it's the same thing. Even if the name was different a little bit, it was containing 082G in the data sheet, but wasn't only 082G the name of the integrated circuit. So this is it. with the tests. I hope you like my power LEDs that I smuggled. No, not smuggled. That I took them out from the boards, and nothing else to say. Yeah. Well, I here with this circuit I tested on 220 volts with a resistor, with multiple resistors. And those resistors, this I think is a good LED, not a bad LED. It's a good category LED. Also at 8 volts, this one. And all the resistors were burned. A visible fume was getting out of them. And then the capacitive dropper that I built, but is limiting. This is the capacitive dropper. Actually, I have more capacitive droppers. This is the bridge rectifier, the semi-D bridge rectifier. This one, the black one, and the rest. And this is unfortunately 100 nanofarads at 630 volts. 630 volts. And 100 nanofarads. I wished I had bigger values capacitors, but I don't have. I have 100 of them. Specifically, I buy them from eBay for this kind of capacitive droppers circuits. And with this one is limiting the power LED. Doesn't matter which category of LED I'm using, the good ones or the bad ones, is limiting under 10 milliamps. These ones actually they work at under 10 milliamps, so the capacitive dropper is perfect for the bad ones, to power the bad ones. But for the good ones, they required more current, and this is just keeping them under it. And yeah, it's kind of good for the good LEDs, but I will see if I can make with I have a lot of bad ones. And I will try to make a board with them to light, very dim light, the maximum light that they can provide, and use it as a paper transfer. You know, when you put one paper with a drawing and another clean paper on it, over it, like you are putting it on a glass, on the glass outside, with the lights with the daylight coming through the papers, and you draw over it. So that's a project that I wanted to make it a very long time ago, and I think these are natural born for this project, the bad ones, the bad category of LEDs. Yeah, so yeah, this is it. This is all the testing, and I really hope you like it, and we will discuss further next sessions, because my final goal is to power them all, the good ones 8 volts and 180 milliamps, I think it was, and the bad ones, which is also 8 volts but very low amperage, and I want them I want a way of calculating the circuit, and the power supply, I mean, for them, a way of calculating it, and practical to see it work. That's all. These two goals to achieve. Hopefully, with your help, guys, from AAC forums, all about circuits website forums. So you are great, guys. You are phenomenal.